Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2020, Paper 2, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to go through June 2020, Paper 2, Higher Tier Calculator paper. Strangely, it's listed on the AQA website as November 2020 if you tried to find a hard copy of the paper, but on the front of the paper it's definitely marked June. Let's get cracking. Question 1. Which of these is a correct identity? Circle your answer. Okay, now you can tell these are identities, not equations, because of the triple equals sign in the middle. Okay, now what is the difference between an identity and an equation? An equation is true for 1 or 2 or 3 or 5 or some values of x, whereas an identity is true for all values of x. Okay, so if you have a look at some of the things we got here, let's take this second one, 6x equals 18. That is true when x is equal to 3. 3 lots of 6 is equal to 18. But it's not true when x is 4. Or 5 or any other value. So this is true for a particular value of x, but not all value of x, so it's not that one. You can do the same thing with 2x plus 1 is equal to 7. It's an equation in x. It's true for a particular value. I think x is equal to 3, but it isn't true for any others, so it's not that one. And same for this one at the end. Now, the first one is true for any value of x. If you make x equal to 2, then x plus 4x would be 2 plus 8, which is 10, and that is the same thing as 5 lots of 2. And that works if you subbed in any value of x. It's always going to be true. So that is the identity. It's always true for all values of x. Question 2. Circle the reason why these triangles are congruent. Right, so I've got two triangles here. Now this side here matches with this one, doesn't it? And this one matches with this one. And the angles in between match. So this is an example of side angle side, because I've got two sides and the included angle that match up. So it's going to be this one, SAS. Question 3, circle the number that is written in standard form. Now, a number written in standard form is made up of two parts. It is made up of a mantissa part, which is the number part at the front. And that number part needs to be a number between 1 and 10, which rules out this one, because 0.9 is not a number between 1 and 10, and it rules out this one because the number 12 is not a number between 1 and 10. Okay, as well as the mantissa part, you have the exponent part, which is a power of 10. So I've got 10 to the 0.5 and 10 to the minus 4 here. Now the exponent, the power, needs to be a whole number for a number in standard form, so it is not that one. That leaves us with this one here, which is the number in standard form. Question 4, circle the expression that has the largest value when a is less than minus 1. Okay, so if a is less than minus 1, then half a, so if a is less than minus 1, then half a is going to be less than half of that, isn't it? Minus a half. That's just a is less than minus 1. A squared, if a is less than minus 1, then a squared is going to be less than minus 1 squared. In other words, a squared is going to be less than 1. And then a cubed, if a is less than minus 1, then a cubed is going to be less than minus 1 cubed, which is a cubed is less than minus 1. Okay, so the largest value there then is going to be this one here then, isn't it? A squared is less than 1. So presumably it's that one there. Question 5. The time spent watching TV was recorded. The table shows the average time per student each year from 2012 to 2019. A time series graph is drawn to represent the data. The first 4 points have been plotted. And part A says complete the graph. So 2012 has been plotted at 157. So like this point here has been plotted. It's that one there. And then we've got 2013, which has been plotted here at 148. And then I've got 2014 that's been plotted here. And I've got 2015 that's already been plotted here. So I need to plot 2016 up to 19 onto the graph. Okay, so if you have a look at the scale is going up in tens, and I've got 5 divisions between each main scale point. So it's between 60 and 7, you've got 5 little squares. So each one of those must be 2. Okay, so 2016 on my scale, I've got to put a mark at 113. So I'm going to come up like 1.5 little squares above 110 to mark 113. So it's going to be there. Okay, and then the next one along 2017 is at 100. That should be fairly easy to plot. It's just on the whole line. Then 2018 is at 90. Again, very simple to plot that one. And then finally 2019 is at 82. So that's going to be one little square above 80 then, isn't it? It's going to be there. Okay. Once you've done that, let's just join them up with straight lines. Okay. It says use your graph to estimate the average daily time per student in 2020. Okay, so I'm going to assume that this is kind of falling linearly. It's kind of not quite linear, is it? Kind of bibbles around a little bit, but a bit like a line of best fit. I'm going to draw a line through those points as best I can. And I'm going to use that to estimate what it is at 220, or 2020, sorry. So 2020 would be the next unit up on the scale here, wouldn't it? 2020. So taking my ruler, read it up to the curve. And then along. That seems to be around about 71, 72. Okay, I'm going to write down 72, I think. So 72 is my estimate. But again, if you do your graph slightly differently, you're going to get a little bit of leeway on that. So just check your graph, read across like I have, and read off your number as best you can. Question 6. Work out the highest common factor, HCF of 75 and 105. You've got different approaches for doing this. Either you can find all the factors of 75 and 105 and then find which one is biggest on both. So what goes into 75? 1 goes into it and 75. 2, no. 3, yeah, 3 goes in and 25. 4, no. 5 does though. 5 and 15. 6, nope, don't think so. 7, nope. 8, nope. 9, nope. 10, nope. 11, nope. 12, nope. 13, nope. 14, nope. And then I've kind of met myself coming back down the other way. I could do the same thing with 105. 1 and 105. 2, no, 3. Yeah, 3 goes into 105, doesn't it? It goes in 35 times. 35, 90, yeah, 35 times. 4, nope. 5, yes. 5 goes in 21 times. 6, nope. 7, yes, 7 does. 7 goes in 15 times, doesn't it? 7 15s. 8, nope. 9, nope. 10, nope. 11, nope. 12, nope. 13, nope. Okay, so it's just I've kind of met myself coming back down the other way again there. So there are all the factors of 105 and 75. The common factors are 1, 3, 5, 15, and that's it, isn't it? Yeah. So the highest common factor then is going to be the biggest one in that list. It's 15. Okay. So it's 15. So you could do it that way. There is an alternative approach using prime factor decomposition. If you type into your calculator 75 and equals and then press shift fact, it will rewrite your number in what we call prime. It's product of prime factors. So 75 is equal to 3 times 5 squared, or 3 times 5 times 5, and 105, I'll do the same thing. 105 shift fact gives me 3 times 5 times 7. So basically what you do is you see what are on both lists. So I've got 3 on both lists and I've got a 5 on both lists. So then the HCF is made up of 3 and 5, which is 15. So probably this method here is the quickest in this situation. Rather, it took me a bit longer to find all the different factors, and there is a danger of when I find all the different factors, especially if the number is large, that I miss one out. Okay, so I might actually miss a pair or don't realize one divides by another. In exam pressure, it's possible. So you know, if you can master this method might be quicker and more reliable in the exam. Okay, right, let's move on. Question 7. Here is the graph of y equals x squared minus 7x plus 10 for the values of x from 0 to 7. Part A says write down the roots of the equation. X squared minus 7x plus 10 is equal to 0. Okay, now this is a quadratic curve I've drawn. And the roots of a quadratic are where it crosses through the x-axis. So if you have a look at the x-axis here, it cuts my graph in 2 places, at this point here and this point here. Okay, so the roots are going to be those values. So it's going to be when x is equal to 2 and when x is equal to 5. They are the roots. Write down the x-coordinate of the turning point of the curve. Now the turning point is the lowest point on the curve. That is this point here, isn't it? Okay. So it's just a little bit under minus 2 in the y direction. In the x direction, let's just read up from that point to the graph. You can see it's smack bang between 3 and 4. So the x-coordinate of the turning point is going to be halfway between 3 and 4, which is 3.5. Okay. Question 8. At a party there are 90 people. 48 are women and 42 are men. Some women leave. Some men arrive. The ratio of women to men is now 10 to 11. Are there now more than 90 people at the party? And I can either say yes, no, or cannot tell. Okay, so let's think this through. So there are 90 people at the party, 48 women and 42 to men. So at the start of the party, the ratio of women to men is 48 to 42. Okay, now some women leave, so this number here is going to go down, and some men arrive, and this number here then is going to go up, and the new ratio is going to be 10 to 11. Okay. Now, can I make a kind of equivalent ratio out of 10 to 11 that accommodates that situation up there? Okay, now let's just think of all the multiples of the ratio 10 to 11, or the equivalent ratios. So if I multiplied both parts by 2, for instance, the ratio would be 20 to 22. If I multiplied it by 3, I would get 30 to 33. If I multiplied it by 4, I'm going to get 40 to 44. Okay? So, is there any other possibility? Now, if I multiply it again, I'm going to get 50 to 55. Now, just think. Let's have a think about which one of these ratios actually could work with the numbers 48, less than 48, and more than 42. Okay. The first one, 10 to 11. 10 is less than 48, but it's not more than 42, so it's not that one. Okay. 20 to 22. 20 is less than 48. 22 is less than 42, so that one doesn't work. 30 to 33 doesn't work. This one does work though, isn't it? Because if 8 women left and 2 men arrived, then this one could work, couldn't it? It could be 40 to 44. And then what about the other one, 50 to 55? That one doesn't work again, does it? Because then there are too many women. That means the number of women would have gone up rather than down. Okay, so there's only one possible scenario it could be. It must be that there are 40 women and 44 men. Okay, so if there are 40 women and 44 men, then the total number of people at the party is going to be 40 plus 44, which is 84. Okay, so are there now more than 90 people at the party? No, there are not, because there are 84. Okay, question 9. Here is a cuboid. Assume that the total surface area of the cuboid is 200 square centimeters. Work out the volume of the cuboid. Okay, well, the total surface area is going to be made up of the areas of the 6 faces of your cuboid. Okay, so I've got 2 identical faces here and here, haven't I? They're both going to be 5 times 5. Okay, so I'm going to get 5 times 5, and I'm going to have 2 of those. Okay, and then I'm going to have the top and the bottom. Now that is going to have a side of 5 and y. So if I multiply those together, I'm going to get 5y. Okay, so I've got 5y for the top and 5y for the bottom. So I've got 2 of those, isn't it? I've got 5y times 2. What about the front and the back face? Now again, the front and the back, this face here and the back one, okay, are going to be 5 times y again. So I'm going to have 5y for the front face and another 5y for the back face. Okay, so what's that all together then? So 5 times 5 times 2, 5 times 5 is 25, times 2 is 50. 5y times 2 is 10y. 5y times 2 is 10y. So adding all that up, I'm going to get 20y plus 50. Now I'm told that the total surface area of the cuboid is 200. Okay, so that means that 20y plus 50 must be equal to 200. Okay, so subtract 50 from both sides. That's going to tell me that 20y is equal to 150, and then dividing both sides by 20 then. That's going to tell me this cancels with this, leaving me with y equals 15 over 2, 7.5. Okay, so that's the length y is 7.5. So then the volume of the cuboid is length times width times height, which is 5 times 5 times 7.5. So reaching for the calculator because I'm feeling a bit lazy. 5 times 5 times 7.5. That comes out to be 187.5. Okay, 187.5 cubic centimeters. Part B says, in fact, the total surface area of the cuboid is smaller than 200 centimeters squared. What does this mean about the volume of the cuboid? Tick one box. Okay, so if you remember, we had the formula 20y plus 50 equals 200 to work out y. Now, if 200 is not 200, but it's smaller than 200, that must mean that when we found that 20y is equal to 150, if 200 was smaller and I took 50 away from it, I'm going to have an even smaller number here, which means that y must have been smaller than 7.5 then. Okay, so it's not 7.5, it's smaller than 7.5. So then the volume, which was 5 times 5 times y is going to be smaller than it was. So then we multiply those three things together, the volume is going to be smaller than it was. Okay, so it is smaller than the answer to part A. Question 10. Alex and Bev sat 6 tests, each with 50 marks. The table shows their mean percentages after 5 tests. So Alex is on 60 and Bev is on 52%. After all 6 tests, their mean percentages are equal. In the 6th test, Alex scored 24 out of 50. Work out Bev's score out of 50 in the 6th test. Okay, so they did 6 tests, but the mean of that we've been given here is the mean for 5 tests. So this is what the mean score that Alex got in 5 tests. So on average, in those 5 tests, he scored 60%. So altogether in those 5 tests, if I take 60 and I multiply it by 5, he scored 300% in all 5 tests added together. Whereas Bev scored 52 times 5, which is what, that's 260%, isn't it? Okay, so she scored 260% in those 5 tests. Now in the 6th test, Alex scored 24 out of 50, didn't he? So that as a percentage is just double 24 and 50. You're going to get 48 over 100, so that's 48%. So adding that onto his 5 tests means that in total over the 6 tests, Alex got 348% in total. Okay, so then if Bev is going to move from 260% up to 348%, she's got a lot to do, isn't she? She's going to have to add on another 88% then there, isn't it? So 260 plus 88 would take you to 348. Okay, so that means that Bev So that means Bev would score 88% in final test, but it wants it as a score out of 50, annoyingly. Okay, so then we're going to have to convert that back then. So if she got 88%, then that is going to be 44 out of 50 then, isn't it? Okay, so that's her final answer, 44 out of 50. Question 11. A solid piece of silver has mass of 2.625 kilograms and a volume of 250 cubic centimeters. Work out the density of silver. Give your answer in grams per cubic centimeter. Okay, so the formula for density is mass divided by volume. Okay, so subbing in our mass, we just need to make sure we've got the right matching units. Now the answer is looking for grams per cubic centimeter. Okay, so our volume's already in centimeters, so that's fine, but this up here is in kilograms, isn't it? Okay, so we need to convert this into grams before we sub it into the equation. Now there are 1,000 grams in 1 kilogram, aren't there? So 1 kg equals 1,000 grams. So if I multiply 2.625 by 1,000, I will convert it from kilograms into grams. So that is 2,625 grams. Okay, so then sub in my newly converted mass into the formula. I'm going to get 2,625 divided by my volume of 250. So what's that then? 2,625 divided by 250. That comes out to be 10.5. So it's going to be 10.5 grams per cubic centimeter. Question 12. Work out the gradient of the straight line through -2, 3 and 1, 9. Okay, now there's a handy formula for working out the gradient. It is gradient is equal to y2 minus y1 over x2 minus x1. Okay, so what are y2, y1, x2, x1? Well, the first coordinate there has values x1, y1, and the second coordinate has values x2, y2. So y2 then is going to be that second value there. It's going to be the 9. y1 is going to be that value there, which is the 3. And then x2 is going to be that value, which is the 1. And x1 is going to be that value, which is the -2. So subbing those carefully in, y2 is 9 minus y1, which is 3, divided by x2, which is 1 minus -2 for x1. Okay, so I've got 9 minus 3 over 1 minus -2. Okay, well 9 minus 3 is 6. 1 minus -2, 1 minus negative, same as adding, it's 1 plus 2, that's 3, 6, 3, that's 6 divided by 3, gives me a gradient of 2. Gradient is 2. Question 13, the diagram shows a wall. The area of the wall is 39.2 square meters. Work out the length of the wall. Okay, so this 39.2 square meters is the area of this shape, isn't it? So this is 39.2 square meters. Now, what sort of shape is it? Hopefully you can see it's a trapezium. And the formula for the area of a trapezium is equal to a half times a plus b, where a and b are two parallel sides, times h, which is the distance between them. Okay? Now, a in this case is going to be this length here, and b is going to be its parallel length over here. So basically what we're doing is going to add them together and divide by 2, or in other words, you're averaging out those two sides, aren't you? So when you find the area of a trapezium, you average out the two parallel sides and then you multiply it by that distance between them, which in our formula is h, but in our diagram is length, or L, I'm going to say there. Okay, so I'm going to take the information from the diagram, I'm going to sub it into that formula, and then we're going to see if we can find out what that length is. Okay, so area we know is 39.2, and that's equal to a half times a, which is 2.8, plus b, which is 2.1, times h, which in this diagram is L. So I'm just going to change the letter over to L. Okay, now what's going on in that bracket? I've got 2.8 and 2.1, so adding those together, 4.8, 4.9, so that's going to be half of 4.9. Okay, now I need to get L by itself, so I need to do the opposite of halving, which is times in by 2 to get rid of that. So I'm going to times this by 2, and I'm also going to divide by 4.9, okay, to get rid of that. Okay, and that will leave me with just L on the left then, won't it? So L is equal to 2 times 39.2 over 4.9. So tapping that into the calculator, 2 times 39.2 divided by 4.9, that comes out to be 16. So L equals 16. Question 14. A marathon takes place each year. In 2020, there are 6,500 runners. The prediction is for each of the next 3 years, the number of runners will increase by 5%. Does this predict that in 2023 there will be more than 7,500 runners? You must show your working. Okay, so this is it's a bit like a compound interest question, isn't it? It's what we call growth. And it's a bit like a percentage problem. So for all percentage problems, I use FOM. Stick your FOM on it. So FOM. What's F? What's O? What's M? F stands for the final. That is what we're trying to predict. That's what we're trying to work out. How many runners there are in 2023. Original is the amount of runners that we start with, which is 6,500. Multiplier, now it's an increase of 5%. So if I've got 100% and I add on 5%, that gives me 105%, which as a multiplier is 1.05. So M is 1.05. Okay, so then covering up the thing I want to find the final. It tells me what to do with the other two things. Stick my thumb on the F. Tells me that final equals original times multiplier. Okay, now we've got compound interest here, or growth. So there's one addition to this. We need to raise that to the number of years. And how many years is it? Years is 3, isn't it? So it's going to be 6,500 times 1.05, but that is raised to the power of 3. Basically, you're multiplying by 1.053 times, aren't you? Okay, times 1.05 times 1.05 times 1.05. So type that into the calculator. 6,500 times 1.05 to the power of 3. That comes out to be 7,524. I'm going to write 25. I'm going to round it up to the nearest person. So I'm going to say that is equal to 7,520. Oh, I say we're going to round up 25. So does this predict that in 2023 there will be more than 7,500 runners? The answer, of course, is yes. This does predict 7,500 plus runners. Okay, so it's important that we answer the question in these. If you just write 7525, you're assuming the examiner knows what that means and you know what assumptions make. So let's not do that. Question 15, rearrange A equals B over C plus 5 to make C the subject. Okay, this is quite a tricky rearrangement because the thing we want to find is on the denominator, which means we have to move it first, so it becomes on the top of the equation, you know, on the top rather than on the bottom. But we can't move it first because of this 5 on the end. That's what we're going to have to move first. So we're going to have to move the 5 over first and then kind of get the C to go from the bottom to the top and then start rearranging to make C the subject. Okay, so we've got a bit of groundwork to do before we can start making C the subject. So let us start by subtracting 5 from both sides. That's going to give me A minus 5 is equal to B over C. Okay, and then to move the C from where it is to there, look, what we're going to do is we're going to times both sides by C. Okay, so then that C will cancel with that. Remember, when I multiply through, I'm not just multiplying A, I'm multiplying A minus 5 with C. So that's going to give me C lots of A minus 5 is equal to B. Okay, then finally to get C by itself, I could just simply divide through by that bracket. Okay, so dividing both sides by that bracket is going to give me, these are going to cancel. And that's going to leave me with C is equal to B over A minus 5. Okay? It's a bit of a tricky rearrangement, that one. It always is when the thing that you're looking for is the denominator. You just have to be careful about how you move it around. Question 16. On a restaurant menu, there are 22 dishes, of which 4/11 are gluten-free, 7 rice dishes, which are all gluten-free, and 5 naan breads, of which 40% are gluten-free. This meal deal is on the menu. Choose one main dish, one rice dish, and one naan bread. How many of the possible meal deals are totally gluten-free? Okay, so let's work out how many gluten-free dishes we've got to pick from our 3 different choices. Now, if I've got 22 main dishes, of which 4/11ths are gluten-free, 22 times 4/11ths, 22 divided by 11 is 2, times 4 is 8. So we've got 8 mains which are gluten-free. We've got 7 rice dishes which are gluten-free because they're all gluten-free. Now 40% of the naan. What's 40% of 5? 5 times 40%. 40% is 4/10, isn't it? 40 over 100, 4/10, which is 2/5. Divide 5 by 5 times it by 2 is 2. It's going to be 2 naan breads, isn't it? Okay, so that means how many different choices are there? You've got 8 choices for your main dish. You've got 7 choices for your rice dish, and you've got 2 different choices for your naan dish, which altogether is, what, 8 times 7 is 56, times 2 is 112. I make that 112 separate choices which are gluten-free. Question 17. The cumulative frequency graph shows information about the masses of 200 apples. Part A says estimate the median mass. Okay, now the median is going to be halfway through our data set. When the number of points is small, it's better to add 1 and before you divide by 2, but when you've got 200, probably the easiest way is just divide straight by 2. That means I need to look across from 100 to find the median. So find 100 on my cumulative frequency, read across to the graph, change direction, read down. Actually drawing the lines on it like this is good. Good method to show. So it's a good idea to do it. So what's that then? It's between 80 and 85. So I've got 5 divisions between 80 and 85. Each one is worth 1. That's going to be 83 grams, then, isn't it? So the median mass is going to be 83 grams. B, apples with mass 90 grams or less cost 32p. Apples with mass of more than 90 grams cost 39p. Estimate the total cost of the 200 apples. Well, 90 grams is here, and if I read up to the graph and across from 90, just switch color, let's go for red. It's going to go up to the graph there, change directions, and read across to the axes. Make it about there. Now what's that? So I've got 140 and 160 here. I've got 5 divisions in between spanning 20 points. So each division must be 4. So it's going to be 140, 44, 48, 52, 56. That's 156. Okay. So that means that 156 apples are going to be 90 grams or less, which means the remainder, which is 44 apples, are going to be more than 90 grams. Okay, so then the total cost is going to be my 156 apples at 32 pence. They were the cheaper ones, weren't they? Plus my 44 apples at 39 pence. Okay, I think that's gone a little bit off the screen. Let me just budge that over so you can read it. Type that into the calculator. 156 times by 0.32 plus 44 lots of 39 pence. That comes out to be £67.08. So So that's equal to £67 and 8 pence. Question 18. This shape is made from two right-angled triangles and a rectangle. Work out the size of angle X. Okay, so I think what we're going to have to do first, we're going to have to find the length of this line here, aren't we, first? Okay, because once we've got that, then we've got this line here as well, because they're the same. And then we'll know two things in this triangle, which we can then find X from. Okay, so we're going to start with the triangle on the left. We know the angle and we know the adjacent. This is the adjacent side. This is the hypotenuse. This is the opposite. Okay, so we're going to use trigonometry. And we're going to have to work out which bit of trigonometry we're going to use. So it's time to think of our handy mnemonic SOHCAHTOA. Okay, so which one has got the O and the A in it then? Because I want the O and the A. So the O and the A is there. Look, we want this bit, the TOA part. Tan theta equals opposite over adjacent. Okay, so that's what we're going to write down. Tan theta equals op over adj. Okay, subbing in what we know. Tan 62 is equal to the opposite. That's what we're trying to find. Let's just call it X. So X over 5. So rearranging, times in both sides by 5 is going to move that over there, isn't it? So I'm going to get X equals 5 tan 62. What's that? 5 tan 62. That's 9.40. I'm just going to leave that calculator display to one side. I'm going to reuse it again in a minute. Now, in the next triangle, I now know this side here, X, which is 9.40. And that is the opposite, isn't it? It's opposite angle X. 12 is the hypotenuse. Again, so SOHCAHTOA on this triangle, SOHCAHTOA. This time, I've got the opposite and the hypotenuse, which is there. I want the sine this time. Okay, so I'm going to write down sine theta equals opposite over hypotenuse. I'm going to sub in what I know. Sine x equals my opposite. So I'm just going to, it's 9.40 divided hypotenuse, which is 12. Okay, so then x is going to be, to get x by itself, I've got sine x, I want to get x by itself, so I need to do the opposite of sine. Now the inverse sine to the minus 1 of 9.40 then over 12. That's what we're trying to work out. Okay, so I'm going to type into my calculator shift sine to get the inverse sine. I'm going to use the answer key because that had my previously stored value in there, and I'm going to divide by 12. Okay, so that comes out to be 51.6 or 59 rounded up. So that rounds up to 51.6 degrees. Okay, so that's my angle, 51.6.
Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths.
Question 19. A and B are positive values. Show that 7a plus 2b minus 3a all over 8a plus 6b plus 2a minus b always simplifies to the same value. Okay, right, so I think first off we're going to collect like terms, aren't we, because we've got lots of a's and b's that we can collect together. So I've got 7a minus 3a, 8a plus 2a, and I've got lots of different b's. Okay, so let's collect those like terms together first. So 7a minus 3a is 4a, 4a plus 2b on the top, and on the bottom then I've got 8a plus 2a, that's 10a, 10a plus 6b minus b, that's 5b. Okay, so I've got 4a plus 2b on the top and 10a plus 5b on the bottom. Okay, now let's do some factorising. On the top there, I've got 4a plus 2b. 4 and 2 have got a common factor. They've got 2 in common. So I'm going to take 2 out right at the front, and then inside my bracket, 2 times what is 4a is 2a, 2 times what is 2b is b. So I've got 2 lots of 2a plus b on the top. On the bottom, I've got 10a and 5b. 10 and 5 have got 5 in common, so I'm going to factorise 5 out of these two terms. So if I take 5 out of 10a, it leaves 2a, and if I take 5 out of b, it leaves b. And look, lo and behold, I've got 2 lots of 2a plus b over 5 lots of 2a plus b. So these two things are the same, so they cancel, and that just leaves me with 2/5. Okay, now can you see there are no a's and b's left in the answer? So that means it doesn't matter what the value of a and b are, because the answer is, well, it doesn't matter what it is, because the answer is always going to be 2/5. So if you change the value of a, you're not going to change the answer, it's still going to be 2/5. So the answer is always 2/5. Question 20. A, B, B, C, C, D, and D, E are 4 sides of a regular decagon. Work out the size of angle W. Okay, so we had a regular decagon. A decagon is a 10-sided shape. We've only got 4 of the sides shown here, so there would be another like 5, 6, 7, 8, 9, 10. Okay, so it's a 10-sided shape of which part of it has been cut off, isn't it? Okay, so we've cut a little bit of the decagon off, and it's left me with this shape here. Okay, so in a regular decagon, which is a 10-sided shape, what is that angle there? Okay, well, a decagon has got 10 sides, n is 10. Okay, so then the interior angles of a regular n-sided polygon is going to be n minus 2, the number of triangles inside the shape, times 180. That will give you the total, won't it? Okay, and then if you divide it by n, you will get the individual angles inside a regular n-sided polygon. Okay, so what we want is n minus 2, which is 8. 8 times 180 divided by 10. That will tell me what C and B and D are. So 8 times 180 divided by 10, that comes out to be 144. Okay, so that means that's 144, that's 144, that's 144, because they're just like the normal angles inside the decagon. Okay, now unfortunately these are not 144, are they? They got chopped off because the actual angle, the side would have gone down like that, so that would be 144. But that bit's gone. We've been left with like partial angle W. Now if you think about it, our new shape, even though it was a decagon to start with, is no longer a decagon. Now it's a 1, 2, 3, 4, 5-sided shape. It's a pentagon. Now it's not a regular pentagon, but it's a pentagon nonetheless. So the interior angles, or the sum of the interior angles of a pentagon, sum of interior angles of pentagon, that's going to be, well, the same formula, isn't it? It's n minus 2, but this time it's got a 5-sided shape, so it'd be 3 times 180 it adds up to. I want the total angle, so I'm not going to divide by 5 this time. So the 3 lots of 180, that is 540 then, so it adds up to 540. Okay, so that means the 5 angles added together are going to be 540. So my 144 and the 144 and the 144 and the W add up to 540. Okay, so 3 lots of 144, what's that? 3 times 144, that comes to 432. So I've got 2W plus 432, that's equal to 540. So then take in 432 from both sides, that's going to leave me 540 minus 432, that's 108. So 2W is 108, which means that W is half of that. It's 54 then, isn't it? Okay, so W is going to be 54 degrees. Question 21a, circle the point that is on the graph of y equals 1 over x. Now, y equals 1 over x is what we call the reciprocal curve. So it looks, if you were to draw it, not that you need to draw it here, but if you were to draw it, it would look like this. Okay, so two parts of the curve which are getting closer and closer to the x-axis and the y-axis, but never touching them. And the thing about it is that your y-coordinate is the reciprocal of the x-coordinate. Okay, so it's not that one. So it's, if I put -1 in there, I'd get 1 over -1 would be -1. If I put 0.3, 1 divided by 0.3 is not 3. So it's not that one either. 1 divided by 0.8 is not 0.2. I don't believe it's that one either. What about this one? Let's just double check this one. 1 divided by 2.5. 1 divided by 2.5. That indeed is 2/5, which is 0.4. So it's going to be that one there. 21b, Leo wants to draw the graph of y equals 2 to the power x for values of x from 0 to 4. Here is his graph. Make one criticism of it. Okay. Now I just had a scan through. Normally it's the axes that are wrong. I just scanned through that. That is fine. That's going up in even increments. So is this one. That's all fine. I've got the axes labeled. The graph is labeled. That's all nice. And I've got a curve joined with points joined up with a curve, so that all looks fine as well. So what could it be? What is wrong with this graph? I think we're going to have to check each value because there isn't anything more obvious wrong with this graph. So we're going to, I'm just going to use the table function in the calculator to do this then. I don't know if you used it before, but if you go to menu and go to mode 3, which is table mode, then you get this f of x turn up. So I want to go 2 to the power of, and then I want to put the little x in, which is alpha, and then the right bracket that you see has got a little x on the top there, the red x. So that's my function, f of x equals 2 to the power of x. I don't need g of x. I can put two functions in, but I don't need it. My start value, I'm starting here on the x-axis, 0. So I'm going to start at 0, and I want to go up to 4, which is, and I want every number in between, so I want to go up in ones. Now if I then press equals, I get a table of values for my graph. I'm just going to copy those down, so x and y. So I've got 0, 1, 2, 3, 4, and I've got 1, 2, 4, 8. If I scroll down a little bit, 16. Okay, right, so they're the points that I should have on my graph. Now, do I have those points? Let's just double check. 0, 1, that's there, that one's okay. Next one, 1, 2, 1, 2, that seems to be fine. Next one, 2, 4, 2, 4, that one's okay. Next one, 3, 8, 3, 8 is there. Next one, 4, 16, 4, 15. So it looks like that one there is the wrong point. It's in the wrong place. The point should be exactly under that label there. It should be up there, shouldn't it? Okay, so they plotted that point in the wrong place, and that is going to be my criticism. I'm going to say point 416 plotted incorrectly. That is my criticism. Question 22. One of these graphs is of y equals 1 plus sine x. Circle the letter of the correct graph. Okay, well, sine x, y equals sine x, looks like this, doesn't it? It starts at 0, and it does that between 1 and -1, okay, in one oscillation from 0 to 360. Now, if I'm doing 1 plus sine x, I'm taking each of these points and I'm moving it 1 point up. So that one is going to be at 1. This point is going to be up at 2. This point is going to be at 1. This point is going to be at 0. And this point is going to be at 1. So I'm going to get the same shaped curve, but shifted up by 1 unit. So it's a translation of 1 unit up. Okay? So which one is showing me a translation of 1 unit up? Well, it's A, isn't it? Okay, so that's the basic sine curve moved 1 unit upwards. Question 23. Right angle triangle ABC is the cross section of a prism. AB is 5, BC is 12, M is the midpoint of CF, and AM is 16. Okay, work out the volume of the prism. Okay, we've got a little bit of work to do, because to work out the volume of the prism, we're going to need to know the area of the front face, which should not be too easy to too hard to do, because I know I can just find the area of that cross section, can't I? So the area of the cross section is going to be the area of this triangle. So area equals, it's a triangle, so it's going to be half base height. I know the base is 12. I know the height, it's 5. So half of 12 is 6. 6 times 5, it's got an area of 30. Okay, so we're halfway there really. So to find the volume, we need to multiply it by the distance between the front and the back face. So in order to do that, we need to know this length here, CF. We need to know what CF is, and we don't know what it is. What do we know? We know that CM is half of CF. So if I knew CM, I could double it up and I could find CF. But do I know CM? No, I don't. But CM is part of another right angle triangle. It doesn't look it from this diagram, but that's a right angle there, isn't it? If you think about what a prism is, the front and the back face are parallel, and this line is going directly between them. So that is a right angle there. So ACM is a right angle triangle. Just going to draw it again. So the right angle's here. This is C, this is M, and this is A. And what do we know about this triangle? We know the hypotenuse is 16. That's not enough. We need 2 things in this triangle to find CM. We only got 1 thing. Okay? So we've got even more work to do, because I need to find another thing in this triangle before I can then find CM. Now I can do that, I think, from my diagram. I can find this length here, which is the same thing as this one here in my ACM triangle, and I can do that from this right angle triangle here using Pythagoras Theorem. So I've got 5 and 12 as 2 shorter sides of a right angle triangle. So to find AC, I can use C squared equals A squared plus B squared. So this is in triangle ABC. So then that is equal to 5 squared plus 12 squared, which is then AC then. That's what I'm trying to find, isn't it? That's AC. It's going to be the root of that then. So what is the square root of 5 squared plus 12 squared? That comes out to be 13. Should really notice that. It's a Pythagorean triple, isn't it? 5, 12, 13. So that is 13. That is 13. Now, and then my other triangle then, ACM, in triangle ACM, I can now find CM using trigonometry, using Pythagoras Theorem again, can't I? But this time I want to find one of the shorter sides. So if C squared equals A squared plus B squared, then B squared is going to be C squared minus A squared. It's going to be the long side squared, take off the shorter side squared. So it's going to be 16 squared minus 13 squared. So then CM is going to be the square root of that. So it's going to be the square root of 16 squared minus 13 squared. So square root 16 squared minus 13 squared. That comes out to a not so nice number. That is the square root of 87, which is equal to 9.33. 9.33. Okay. So then CF is going to be twice that then. So CF is going to be CM times 2, which is going to be, times that by 2, I'm going to get 18.7. And then so the volume of the prism is going to be the area of cross section times its length, which is equal to 30 centimeters we found earlier, times our length of 18.7. So I'm going to use the calculator value I worked out earlier and times it by 30, and that should give me the volume then. So that is 559.64. I'm just going to round that off to 560 cubic centimeters. Question 24. Work out the coordinates of C when ABCD is rotated 90 degrees clockwise about O, then translated by -6, 2. Okay. If you're not so good with rotation, it's probably best to do this with tracing paper. Just lay your tracing paper over the shape, then trace your shape out, and then hold down your pen at the origin and turn it 90 degrees clockwise. Sometimes helps to do a little cross in the center so you can keep track of how far you're meant to turn. If you do that, you should find that B ends up here. C is going to end up down here. A is going to end up here, and D is going to end up down here. Okay, if you get good at it, you can do it without tracing paper, but you have to be pretty pro, I think, in order to do it. Then join them up with a straight line. Okay, so that's going to be my shape after the rotation. So that is C dash, B dash, A dash, D dash. Okay, and then I'm going to translate it by -6, 2. Now -6, 2, the top digit is in the direction of X and the bottom digit is in the direction of Y. So I need to go -6 digits in the direction of X. That means I'm going to go 6 units to the left and 2 units in the direction of Y, which is 2 units up. Okay, so taking the point B to start with, I'm going to be going 1, 2, 3, 4, 5, 6 to the left, 1, 2 up. Going to end up at that point there, aren't I? Okay, just get rid of that. So that's going to be my B dash. So it's not, it's going to be B double dash. B double dash. Do the same thing with C. So if I start at C and I go 1, 2, 3, 4, 5, 6 to the left and 1, 2 up, takes me to that point there. That's going to be C double dash. Okay, and then A, 2, 4, 6 along, 2 up, takes me to here. Okay, that's going to be A double dash. And then finally D, 2, 4, 6 along, 2 up, takes me to there. Okay, so that then is D double dash. Okay, and again I'm going to join them up into a shape now. Now I've found all the corners. Okay, and that is my new shape. So remember, we needed to work out the coordinates of C. So now C is over here, isn't it? What coordinates is that then? So then the coordinates of C double dash is going to be -5, comma, -2, and is it -5, -2? Okay, -5, -2. Part B says triangle PQR is shown when PQR is reflected in a line. P and R are invariant points. Circle the equation of the line. Okay, now invariant points means that they do not move when the shape is translated. Okay, so the image of P lands on top of P and the image of R lands on top of R. Okay, now the only way that can happen, the only points that are invariant in a reflection are the points that lie on the mirror line. Okay, so the mirror line has to pass through P and R for those points to be invariant. Okay, so I'm going to have a mirror line that is traveling through P and R. Okay, so I'm just going to draw that mirror line in. Okay, so this is my mirror line. Okay, All right, so P and R already dealt with. So if I was to reflect Q, then Q would end up over here, wouldn't it? Okay, so that's Q dash over there. Okay, so that's my mirror line. Now, what is the equation of that line? Okay, that's the line y equals minus x, isn't it? I can tell already. Passes through the origin, so there is no, remember, equation of a straight line of the form y equals mx plus c. Okay, now it passes through the origin, so there is no c because c is 0. It's sloping downwards, so m is negative, and the gradient is -1. For every unit you go to the right, you're going 1 down. Okay, so m is 1, so is y equals minus x. That's the equation. It's that one there. Question 25. Factorize 3x squared plus 11x minus 20. Okay, now if this factorizes, it's going to factorize into 2 brackets like this, isn't it? Okay, and the terms at the front multiply together to give you 3x squared. Now 3 has only got factors 1 and 3, so the only way to make 3 is to have a 3 here and a 1 in the other one, or in other words a 3x here and a 1x over here. So I'm going to have 3x and 1x at the beginning of my brackets. Now the other number at the far end, you have to, when you multiply it together, you're going to get negative 20. Okay, so what are the factor pairs of 20? How many different ways are there of getting 20? I could have 1 and 20. I could have 2 and 10. I could have 4 and 5. That's it. So they're my 3 possibilities. Okay, now one is going to be positive and one is going to be negative. So I'm going to have to just try each of those combinations inside this pair of double brackets to see if I can get plus 11 when I add it together. Okay, so if I put the 1 here and the 20 here, that would give me 3 lots of 20. It would give me 60 and 1. And if I had to take one away from the other, I'm not going to get 11, so that isn't going to work. So let's try it the other way around. Let's try the 20 and the 1 there. 3 times 1 is 3, 20 times 1 is 20, 20 take away 3 is not 11, so it's not that way around either. So we've exhausted our possibilities there. Let's try the next combination, 2 and 10. 2 and 10, so if we put the 2 there and the 10 there, 3 times 10 is 30, 2 times 1 is 2, 30 take away 2 is 28, doesn't work. Okay, try it the other way around. 10 and 2, does that work? 3 2s are 6, take away 10, it's going to have a difference of 4, that's not going to work either. Finally, I've got 4 and 5, let's try that. So if I put the 5 here and the 4 here, 3 times 5 is 15, take away 4, that does give me 11, okay? So if I put a plus this side, it's going to be plus 15, minus 4 there. That's it then, isn't it? 3x minus 4, x plus 5. Okay, that's it, factorized. Question 26, Edith's van can safely carry a maximum load of 920 kilograms. She wants to use a van to carry 30 sacks of potatoes, each of mass 25 grams to the nearest kilogram, and 20 sacks of carrots, each of mass 7.5 kilograms to the nearest decimal place. Can she definitely use her van safely in one journey? You must show your working. Okay, so I tend to do a little number line. I put on the number in the middle. So if I look at the potatoes, each of the potatoes is 25 kilograms to the nearest kilogram. So the next number up to the nearest kilogram is 26. The next one down to the nearest kilogram is 24. So the numbers that round to 25, sorry, the ones that are halfway between those, aren't they? In other words, between 24.5 and 25.5, they all round to 25. So that's for the potatoes. For the carrots, we are told that they are 7.5 grams to the nearest decimal point. So let's mark 7.5 on our scale. Now 1 decimal point up, it will be 7.6. 1 decimal point down will be 7.4. The numbers that round to 7.5 are going to be the ones that are halfway between those, or closer, which is 7.45 up to 7.55. Okay, Now we want to know if she can definitely use her van. So what we want to consider is the worst case scenario then. Okay, so we want to try and make the van as heavy as it's going to get using the bounds here. Okay, so the total weight of the van is going to be my total weight is going to be my 30 sacks of potatoes. I'm just going to call that 30p, and then my 20 sacks of carrots. Okay, now that is going to be the maximum it's going to be if I pick the largest possible values of p and c. Okay, so I'm going to pick 25.5 as my value of p then. So that's going to be 30 lots of 25.5 plus 20 lots of my heaviest my carrots can possibly be, which is 7.55. Okay, so then tapping that into the calculator, 30 times 25.5 plus 20 times 7.55, that comes out to be 916 kilograms. Okay, so if in the worst case scenario each of those bags were at the very upper limit of what they could possibly be, then still it's less than the 920 grams that she can carry in the car. So my answer would be yes, she can safely carry in one journey. Question 27. These 20 discs are in a bag. 2 of the discs are taken at random from the bag. Work out the probability that the first disc has a smaller number on it than the second disc. Okay, now I could draw a tree diagram here, but it's going to be mighty messy, isn't it? Like if I did like, you know, a tree diagram for all the possibilities, like 11, 22, 33, 44, and then 11, 22, 33, 44, it's gonna end up being a forest. I don't want to do that. So I'm just going to treat each case separately and add them all up at the end. So I'm going to consider case 1, which is that I draw an 11 on the first go, and then case 2, and then case 3, and then case 4. Okay, and then I'm going to add them all together at the end. I think that's going to be the easy way of doing it, I think. Right, so let's consider case 1. I draw an 11 on my first go. Okay, what's the probability of that happening? That is going to be 4 out of 20, isn't it? Because there are 4 11s out of a total of 20. Okay, so work out the probability that the first disc has a smaller number than the second disc. So if it's smaller, then it means that all my other my second selection can't be an 11, but it can be a 22, a 33, or 44, because the first disc has to be smaller than the second disc. So the second disc can be a 22, a 33, or 44. Now, if it's, how many of those are there? There are 2, 4, 6 22s, 2, 4, 6, 7 33s. There are 3 44s. That is a total of 16 altogether. And there are 19 tokens to pick from because I've already picked one. So it's going to be, it's going to be 16 out of 19 then, isn't it? Okay, 16 out of 19. For case 2, let's assume that on my first selection I chose a 22. How many ways is there of that happening? There are 6 of them out of a total of 20. So I've got 6 in 20 chance of that happening. Now, if it does happen, how many of the next outcomes are going to be bigger than 22? Well, it means I must have had a 33 or a 44. 2, 4, 6, 7 33s, 3 44s give me 10 that are bigger than 22 altogether. So that's 10 out of 19. Case 3, I select a 33 on the first pull. Now there is a 7 chances in 20 of that happening. If I do pick a 33, how many numbers are bigger than a 33 for my second draw? There are only 3 this time, isn't it? So that's 3 out of 19. Now, if I picked a 44 on the first go, there's a 3 in 20 chance of that happening. How many counters are bigger than a 44? There aren't any, are there? So that one there isn't going to happen. So that isn't going to be part of my solution, I don't think. Okay, so that happening isn't going to work. So then the probability that my first is smaller than second, that's going to be those three different cases added together then, isn't it? Either we got an 11 at first go and then it was bigger than an 11, or I drew a 22 on my first go and my second draw was bigger than a 22, or I drew a 33 on my first go, sorry, which was 7 out of 20, and then I drew bigger than a 33 on my second go, sorry, and that's it. So quite horrendous, but if I'm careful typing that in with the fraction key on my calculator, I should do all right. So 4 over 20 times 16 over 19 plus 6 over 20 times 10 over 19 plus 7 over 20 times 3 over 19. What would be that then? That is 29 over 76. So there are 29 in 76 chances that that is going to happen then. Question 28. A horse runs in a field. The speed time graph represents the first 12 seconds of the run. After how many seconds has the horse run a distance of 75 meters? Okay. So this is a velocity time or a speed time graph. Now the distance traveled in a velocity time graph is the area under the graph. Okay. So if we can work out the area under the curve or under the graph, we need to work out so that the total distance is 75. Okay. So the graph has got two main areas. It's got this part from 0 to 4 seconds where the horse is clearly accelerating. So it's accelerating from not moving up to a speed of 10. Once it gets to 10, it's just carrying on at the same speed, isn't it? Okay, so that's quite handy. It means we can break our shape down into a triangle, this part here. So let's just divide it up into a triangle and a rectangle. Now I don't know where to draw the line of the rectangle. It's not necessarily at 12. I need to draw the other end of the rectangle at a point which will make the total area be 75. So we're going to have to kind of work backwards a little bit to find that. Okay, let's first off work the area for this triangle. So the area of a triangle is half base height, isn't it? Okay, so this is going to be a half times the base of this triangle is 4 times the height, which is 10. So that's 2 10s, that's 20. Okay, so that's got an area of 20. So it means the horse covered 20 meters while accelerating in that first 4 seconds. Okay, so what's left? It needs to run 75 altogether. So 75 subtract 20, that leaves me with 55. So this area of the rectangle needs to have an area of 55 so that the whole area is going to be 75. Okay, now the height of this rectangle is 10 because that's the height it's at. So 10 times something is 55. What is the something? It's going to be 5.5 then, isn't it? So 55 divided by 10 is 5.5. That means that the other line of my rectangle has to be 5.5 units beyond 4 then, isn't it? So it's going to take me up to 9.5. Okay, so that is 9.5. Okay, giving me an area of 55, a total distance travelled of 75, and that tells me then that the horse has covered 75 meters in 9.5 seconds. So after how many seconds has the horse run a distance of 75 meters? In 9.5 seconds. Okay. Question 29. Solve 5 over 4x plus 1 is equal to 2x over x squared plus 3. Okay, Now the first thing I'm going to do is cross multiply these. So this is going to end up here. This is going to end up here. Why? Because I'm going to multiply both sides by the things that are on the bottom. They'll cancel on one side, reappear on the other. Okay, so what you'll end up with is 5 lots of the denominator that was on the right, x squared plus 3, is equal to 2x times the denominator that was on the left, which is that. Okay, removing the brackets, 5x squared plus 15, that is equal to 2x times 4, 4x is 8x squared plus 2x. Okay, going to collect everything on one side. I think I'm going to move it over to the right so I keep my x squareds positive. So taking 5x from both sides, I'm going to end up with 3x squared plus 2x. Taking 15 from both sides, I'm going to end up with that, aren't I? So 0 equals 3x squared plus 2x minus 15. Okay. Now, we want to solve it, so we're going to, well, it's asking us to show our answers to 3 significant figures. So I'm assuming I cannot factorize here, so I'm not going to bother trying. I'm just going to break out the quadratic formula and try and solve it that way. Okay, so what my values of a, b, and c then? A is going to be my coefficient of x squared. It's going to be 3. B is going to be 2. C is going to be minus 15. Okay, so subbing that into the quadratic formula, x equals minus b plus or minus the root of b squared minus 4ac all over 2a. Subbing in, minus b minus 2 plus or minus the square root of b squared, 2 squared minus 4 lots of a, which is 3, times c, which is minus 15. All over 2 lots of 3. What's that? That's minus 2 plus or minus. I'm going to get 4 minus negative. What's that? 4 times 3 is 12. 12 times 15 is 180. So it's going to be plus 180. 4 plus 180 is 184. So it's going to be 184 over 6. So minus 2 plus or minus the root of 184 all over 6. So that's going to be then that x is equal to, let's type that into the calculator, negative 2 plus the root of 184 all divided by 6. I make that 1.927 to 3 significant figures, 1.93, or just going to press the back button and change my plus to a minus and press equals. That comes out to be minus 2.59, or x equals minus 2.59. Okay, I think we're done.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.